Hi, this is Christina from Northern Michigan University, and I am here to explore the polar rows using Geometer Sketchpad. Different from rectangular coordinates because they're determined by a distance and an angle rather than an x value and a y value. In this case, our example point has the distance of 3 from the origin and negative 120 degrees from the x-axis. These are four commonly used polar equations. First, we have the polar rows. This one has a length of 5 with 9 petals. The Archimedes spiral is pretty cool because it has an equal distance between each of the turns. It never changes. Next, we have the logarithmic spiral, which is different from the Archimedes spiral because the distance between each of the turns is not the same. Lastly, we have the cardioid, which is kind of shaped like a heart depending on the value. Okay, to change the length of the flower petals, we have to manipulate A. And to do this, using Geometer Sketchpad, we are going to attach a point to a slider, measure the distance, and animate the point. And this will allow our flower petals to extend and contract all the way to 0. And once the point has a distance of 0, the equation will cease to exist because the cosine is being multiplied by 0. To change the tilt of the flower, the angle added on to theta must change, which we can do by having angle ABC on a circle, creating an angle changer, and then we can animate point C to extend our angle, and that will allow the flower to rotate. Next, we are going to try to find a way to alter the length of the petals and the tilt at the same time. We're going to do this by using the arc, which has a length of 15.71 and a radius of 5. And then we're going to put a point on the arc. And to get the slider max to change our A, we're going to take half of the arc length, so that when this point is up at the top of the arc, our flower petal will be at its maximum length so that it will contract. To get our circle, we are going to form a relationship between the arc length and the slider, and then we are going to take a fraction of it because we want our circle radius to be quite small so we can have a visually able to see the difference of the tilt. And then we're going to animate it, and you can see that it is changing length and tilt at a constant rate. And then when the point gets all the way to the top, the flower petals will shrink again. And then, as you can see in this drawing, as the sun rises, the flowers start growing and spinning. And when it reaches the top of the sky, the flowers will start to shrink again as the end of the day approaches. And then when the sun reaches the end, the day starts all over again and the pattern continues.